Hello everyone, thank you for signing in and watching my live stream. I'm Mr. Matt and this is Dr. Tot, and welcome to SAT ACT Prep. Today we're going to be talking about, this is the second stream on solving with substitution or solving conceptually. In many SAT and ACT problems, they're going to ask you to verify the veracity or the truthfulness of multiple statements. These are the multi-statement questions. These can be done, there's two methodologies to approach these types of questions. One is a fallback method that is a little bit more time consuming, and that's the substitution. We identify the appropriate domain of each of the unknown variables, we pick appropriate values for those variables, and we substitute them into the expressions and test whether the overall result is true or false. The second way of solving these problems, which is a lot faster and is the higher recommended way, is to solve conceptually. And you do that by understanding the number characteristics involved, whether it be positive versus negative, even versus odd, and you can predict the result of the expression based on your understanding of the relationships and the characteristics involved. So let me go ahead and share my screen with you. Okay, so I want to just go through some number properties first. And these are going to involve the numbers 0, 1, and 2. 0 and 1 in particular are very important numbers in the number system. We see that from the inverse property of addition and multiplication, as well as the identity property of addition and multiplication, which tell us, the inverse tells us that 1, the negative value, anything minus or plus its negative will equal 0. Anything times its inverse, 1 over that value, is equal to 1. So you see the result, the nullifying result, is 0 or 1. Conversely, the additive property, the identity property of addition and multiplication tell us what values times or plus a certain value will retain its identity. So for example, any value plus 0 is that same number. Any number times 1 is that same number. So 0 and 1 have special characteristics, properties, characteristics, however you want to name them, that we're going to want to understand and memorize and be able to recognize in the problems when they're presented. So 0, first of all, a little unknown fact, or underknown fact, I should say. 0 is an even value. So the definition of even numbers is that it's a multiple of 2. So any multiple of 2 is an even value. 2 times 0 is 0. So 0 technically is a multiple of 2. So 0 is an even number. Any number times 0 will result in 0. Any number plus 0 will equal that same value. The same number is unchanging. 0 divided by any number will always be 0. However, any number divided by 0 is a nonsensical mathematical operation. It's undefined, and the result is undefined. The reason for that is that division is the separation of units into equal groups. So you can't take, if we had, for example, 6 cookies, I could split 6 cookies equally among, or I should say between, 2 people. That would be 6 divided by 2, so each person gets 3 cookies. I could also split those 6 cookies among 3 people. So that would be 6 divided by 3, so each person would get 2 cookies. I cannot, however, split 6 cookies among 0 people. That doesn't even make sense. So dividing by 0 is not a plausible, or it's not an appropriate or valid mathematical operation. So any number divided by 0 will always be undefined. 0 is the only number that equals its opposite because, and this goes in line with the last statement, 0 is neither positive nor negative. So 0 is the only value that's equal to its opposite because all values that are positive or negative are defined by 0. So 0 is special in that regard. It lies right in the middle of the number line, and all positive values are merely defined as values greater than 0. All negative values are defined as all values less than 0. So 0 is special. So is 1. 1 has some special characteristics. Actually, let me just backtrack here. This characteristic is particularly important and comes up a lot, and it's really powerful. It doesn't, in how the simplicity in which it's stated there doesn't show the power that that statement has. 0 is a nullifying agent when it comes to multiplication. You could have a million numbers that you're taking the product of, 1,000 times 10,000 times 140 times, go on and on for a million times. If any one of those numbers, any value in that huge string of multiplication is 0, the whole thing goes to 0. So that's a really powerful characteristic that comes up in some of the more logic-based questions. So moving on to 1, first of all, 1 is not prime. The definition of a prime number is that it's only divisible by 1 and itself. 1 is itself, and 1 only has one factor, which is 1. So by definition, it doesn't fit the definition of being prime. So 1 is not prime. If you're asked to evaluate the number of values between a certain interval or between a maximum and a minimum that are prime, you cannot include 1 nor negative 1 because they're not. They're technically considered composite numbers. Second, 1 is the smallest positive integer, so all positive values are greater than 0. And conversely, all numbers greater than 0 are positive, and 1 is the first positive whole number. That's really important because when we go to test values, you want to do it in a systematic way. You don't want to, if you have a certain domain or a certain acceptable interval of values that you can use for inputs in an equation, you don't want to just randomly start picking numbers like, oh, if x is greater than 0, if x is a positive number, let me pick 32 and try it. Let me pick 140. You want to start with the least, or you want to start with a lower or upper bound, depending on the question, and work your way towards infinity to see where the threshold might lie. That otherwise it's kind of a exercise in tedium. So 1 is the smallest positive integer. 1 is an odd number. It's not a multiple of 2. And like I said before, 1 has only one divisor. And that's the only value that has only one divisor. 2 is the smallest positive prime. So I told you that 1 is not prime. So 2 actually is prime, and it's the only even prime number. All other multiples of 2 or all other even numbers are multiples of 2 and therefore have a factor of 2, therefore are divisible by 2, and therefore are not prime. They're composite numbers. Remember, the definition of a prime number is that it's only divisible by 1 and itself. So any other even number other than 2 would be divisible by 2. If you have any questions, then feel free to drop a comment below. Otherwise, I want to also look at some number combinations here, some combinations with operations pertaining to values that have even odd characteristics, and then we're also going to talk about positive versus negative characteristics. So when dealing with addition or subtraction, when taking an even number plus or minus another even number, so for example like 2 plus 4, an even plus an even will always result in a predictable outcome. It will always equal an even sum or an even difference. If you take an even number and add or subtract an odd number, that will always produce an odd result. If you alternate the sequence there, if you take an odd number and you add or subtract an even number, the same thing happens. You will always have an odd result. And if you take an odd number and add or subtract an odd number, another odd number like 3 plus 3, 3 plus 5, that will produce an even result. So these are combinations with even odd characteristics that will produce predictable results. And you can rely on this when solving conceptually in order to cut a lot of time out of your problem solving process. Now with multiplication, it's similar, but just a little bit different. So an even times an even, like 2 times 4. An even times an even will be even. An even times an odd, like 3 times 4 is 12. That will always produce an even. An odd times an even, so if we alternate the sequence again, that's still going to produce an even, like 3 times 4 or 4 times 3. That will always produce 12, which is an even value. But an odd times an odd, like 3 times 5 or 3 times 7, that will always produce an odd. So only an odd times an odd will produce an odd product, but an odd times an even, an odd plus an even, or an even plus an odd will produce an odd sum or difference. If you have any questions, then please let me know. Now with positive or negative combinations, it's important to understand with sums and differences that the result will take the value of the larger the result will take the sign of the value with the larger magnitude. So for example, -8 plus 5, -8 has a larger magnitude than 5. It's farther away from 0 on the number line. So its negativity is going to overtake 5's positivity, and the result will be -3. If you had +2 plus a -3, -3's negativity, or the magnitude of -3, is going to overtake the positivity of 2, and the result would be -1. Now, if you happen to come across a really complex sum or difference statement that has multiple negatives in it, there's a really useful tool called the leave, change, change rule. And these can take really convoluted difference and summation and difference statements and turn them into things that are a little bit more manageable mentally. So for example, -3 minus 5, that might be a little strange to think about or a little difficult to think about. If we do leave, change, change, by recognizing that each number has its own sign, and then you also have the operator, whether it be addition or subtraction. So here, notice the 5 doesn't have a sign attached to it, and that's because in mathematical nomenclature is the standard way of writing or saying something in a particular field. So mathematical nomenclatures, could be described as the way that mathematicians would talk about math or use math. So when we're using math or representing numbers, we usually don't list the addition sign or the positive sign. Just like if we have x, we really know that that means 1x. And really, we know that that means 1x to the 1 power. It's just that the coefficients of 1 are useless there, and so we find them needless and redundant to write over and over again. So we just don't list them, and we just write x. The same thing is true here. We really have a positive 5. This is really -3 minus a positive 5. And so if we go through and do leave, change, change, leave the first sign alone, change the operation, change the sign of the second number. Notice that -3 plus a -5 is a little bit easier to think about or wrap your mind around than -3 minus a positive 5. So -3 minus a -5 would give us a -8. We can see that they're both going in the negative direction, and so they're going to sum to a negative value with a higher magnitude than any of the original values. Again, if you have any questions, then please let me know. Otherwise, let's take a look at these questions. I'm going to give you 5 minutes to look at 1 through 3, and then I'm going to solve number 1 for you and give you an additional 3 minutes to finish 2 and 3, and then we'll move on. I'll keep track of the time in the upper right-hand corner and update it per minute. So you can go ahead and do numbers 1 through 3, please. Okay, so let me go ahead and solve number 1 with you, and then I'm going to give you 3 additional minutes to apply to number 2 and 3. So number 1, these are all symbolism questions. So number 1 says if x at sign y represents the number of even numbers greater than or equal to x and less than y, what is the value of -4 at sign +1? So at sign obviously is not a mathematical symbol, and they can make up symbols at their interest or at their pleasure, as long as they define what the symbol is supposed to represent. And they do, in fact, define it here. They say that it represents the number of even numbers greater than or equal to x and less than y. So what this means is that when they take two numbers and they put at sign in the middle of it, in the middle of them, that they no longer represent those values. They represent the number of even numbers greater than or equal to the value on the left, x, and less than the value on the right, y. Notice that it's greater than or equal to x, but only less than y, not less than or equal to. So it's inclusive to the lower bound of x. It's exclusive to the upper bound of y. So we cannot count the maximum value, but if the minimum value satisfies the condition in which we're looking, excuse me, which is the number of, if it's an even number, then we can count the lower bound. But the upper bound we can't count because it's exclusive. So I'm going to first start with a number line ranging from -4 all the way up to +1. So -4, -3, -2, -1, 0, and then +1. Now I can't count +1, but I can count -4 because it's greater than or equal to -4. So -4 is an even number, -2 is an even number, and remember 0 is an even number. So the answer to number 1 is 3. There are 3 even numbers greater than or equal to -4 and less than +1. So I'm going to give you 3 additional minutes. Please apply those observations to questions 2 and 3. Okay, number 2 asks, if x at sign y represents the number of odd numbers greater than x and less than or equal to y, what is the value of -1 at sign 7? So here they changed the definition. So you can see how these are really logic-based. These are really critical thinking, creative math questions. There's not one overarching formula that I can give you that's going to apply to all of these questions. It's really a reading exercise and understanding the context and what they're asking for and what definition do they provide for the unknown, ambiguous symbol that they're making up. So here they're saying whenever they place two numbers, x and y, on opposite signs of an at sign, it no longer represents those numbers themselves. It represents the number of odd numbers greater than x and less than or equal to y. The number of odd numbers greater than the left number and less than or equal to the right number. So what's the value of -1 at sign 7? So we're going to be going from -1 all the way up to 7. So that's going to be 0, +1, 2, 3, 4, 5, 6, and 7. Now it has to be greater than x, so we can't count the the left-hand value, which is -1, but we can count the 7 because it can be less than or equal to y, less than or equal to +7. So we can't count -1. The next odd number would be +1, then +3, then +5, and lastly we can count +7 because the domain is inclusive to +7. It's inclusive to y. So we have 1, 2, 3, 4 values, 4 odd values greater than -1 and less than or equal to +7. For number 3, if x at sign y represents the number of prime numbers greater than x and less than y, what is the value of -4 at sign +4? So here we're going from -4 all the way up to +4, so -3, -2, -1, 0, +1, +2, +3, +4. And we're talking about numbers greater than x and less than y. So they're both exclusive to the lower and upper bounds of the domain. So we can't include -4 nor +4 even if they satisfy the characteristics in which they're asking for. For which they're asking. So we're looking for the prime numbers. So remember that 1 is not prime, nor is 0. So -3 is prime, -2 is prime, that's a tricky one, +2, +3. So here we have 4 prime values greater than -4 and less than +4. If you have any questions, then please drop me a comment below. Otherwise, I'm going to give you 5 minutes. Please look at 4 through 6, and then we'll go through the solutions. Let me read these aloud, actually. I keep on forgetting to do that, and I want to make that a habit, so I apologize. Number 4 says, if x at sign y represents the number of even numbers greater than x and less than y, what is the value of -7 at sign +1? Question 5 says, if x at sign y represents the number of odd numbers greater than x and less than y, what is the value of -7 at sign +1? And number 6 says, if x at sign y represents the number of prime numbers greater than or equal to x and less than or equal to y, what is the value of -7 at sign +7? 5 minutes. Okay, let's look at number 4. So if x at sign y represents the number of even numbers greater than x and less than y, what is the value of -7 at sign +1? So we're greater than the left and less than the y, exclusive on both the minimum and maximum points of the domain. So we're going from -7 all the way up to +1, so that's going to be -6, -5, -4, -3, -2, -1, 0, and +1. And now we can't count -7 nor +1. But other than that, we're going to count up the even numbers. So we have -6, -4, -2, and 0. So there's going to be 4 values, 4 even values, greater than -7 and less than +1. Number 5, if x at sign y represents the number of odd numbers greater than x and less than y, what's the value of -7 at sign +1? So it's the same type of deal. We're going from -7 all the way up to +1. -1, 0, and +1. Now that's still greater than x and less than y, still exclusive to the minimum and the maximum. So we can't count -7 nor +1, but we're going to count up all odd values other than those two extremes. So we have -5, -3, and -1. We can't count +1 and we can't count -7 because they're exclusive to the domain that's listed. So here the answer would be 3. Number 6, if x at sign y represents the number of prime numbers greater than or equal to x and less than or equal to y, what is the value of -7 at sign +7? So notice greater than or equal to the left number and less than or equal to the y value, or to the y, the number represented by y. So this is an inclusive, these are inclusive values, or these extremes are inclusive to the domain. So if they do satisfy the characteristic for which they're looking or questioning about, then we can count them. So first start with a number line. We're going to go from -7 all the way up to +7. So we're going to have -6, -5, -4, -3, -2, -1, 0, +1, +2, +3, +4, +5, +6, and finally +7. Now remember, we can count the lower and upper extremes, and we're looking for prime numbers. -7 is prime, -5 is prime, -3 is prime, -2 is prime, +2 is prime, +3 is prime, +5 is prime, and +7 is prime. So we have 1, 2, 3, 4, 5, 6, 7, 8 prime numbers that are greater than or equal to -7 and less than or equal to +7. If you have any questions, then again, please feel free to drop a comment below. Otherwise, let's look at some multi-statement questions. So I have 5 of these planned for today. I'm going to give you 3 minutes. I'd like you to look at question number 1, and then we'll go through the answer. Okay, question number 1 says if A and B are odd positive integers and C is an even positive integer, which of the following would be even? Statement 1 says A times B, statement 2 says A times C, and statement 3 says B times C. A is statements 1 and 2 only, B is statements 2 and 3 only, C is statements 1 and 3 only, and D is statements 1, 2, and 3. So here we have two different ways, two methodologies that we can use to solve this problem. One is substitution, the other is solving conceptually. If we solve using substitution, the first thing that we need to do is identify the domain of our values, of our variables, or missing numbers. So A and B are odd positive integers. So if they're odd positive integers, we might want to, you want to pick easy to work with values as well. You don't want to make life hard for yourself on this test. So easy to work with values that are also odd and positive. So maybe A is equal to 3 and B is equal to 5. Those are both odd positive integers and they're pretty easy to work with because they're pretty relatively small. They have low magnitudes or small magnitudes. C has to be an even positive integer. So maybe 2. It's an easy to work with even integer. Now that we have appropriate values that we've picked, given the domain of the variables in the question, we can substitute in and test whether these statements are true or false. If they're true, then obviously we would select them. We would select the answer choice that includes them. If they're false, then we can use that information as well to eliminate any answer selection that contains that false answer, or that false statement. So that's always available to you, but notice that that's a little tedious, and it's also open to a lot of mistakes in calculations. If you do a careless calculation, you might get the statement wrong and get the wrong answer. The quicker way, and the way that I want to suggest you try and solve these problems with first, and use the substitution method as a fallback in case it's overly complex and also you just want to check to make sure the values are true or that your operations and your calculations are true, you want to solve conceptually first. So you want to think about the number characteristics that are relevant given the context of the question. Here they're talking about odd numbers and they're ultimately, well, A and B are odd, C is even, and then they're asking what expressions would result in an even output. So the characteristic that we want to zoom in on here is odd versus even. So if I look at statement 1, A has to be an odd number, B has to be an odd number. So this is really just the same thing conceptually as an odd times an odd. Any odd times any odd will always produce an odd number. So statement 1 is false because A times B, an odd times an odd, cannot be even. Statement 2, A times C. Well, A has to be odd and C has to be even. Any odd times any even will always produce an even result. So statement 2 is true. Statement 3 says B times C. Well, B has to be odd and C again has to be even. So that's going to produce the same result as statement 2, which is going to be an even output. And so statements 2 and 3 are true. And so your answer here would be B. Notice that once I eliminated answer selection A, I would know that the answer was B immediately, because notice that A, C, and D all contain statement 1. So you can use, a lot of students are intimidated by these problems because there's a lot of information in them, but you can use the statements against the question itself. So if you know statement 1 is false, all answer selections containing statement 1 also have to be false. And so usually by proving one statement to be true or false, you can usually eliminate more than one answer selection. So these problems look very intimidating, but they're actually really, really useful, or they're really, it's a great opportunity to use a systematic elimination method. So to eliminate systematically. If you have any questions, please let me know. Otherwise, let's look at question 2. I'm going to give you 3 minutes. Question 2 asks, if A and B are odd positive integers and C is an even positive integer, which of the following would be odd? Statement 1 says the quantity A times B minus the quantity B times C. Statement 2 says 2 times the quantity A times B, quantity minus 3. And statement 3 says 5A times the quantity 2C plus 3B. And answer selection A is statements 1 and 2 only. Answer selection B is statements 2 and 3 only. Answer selection C is statements 1 and 3 only. And answer selection D is statements 1, 2, and 3. I'll give you 3 minutes and then I'll give you the solution. Okay, so looking at number 2, if A and B are odd positive integers, we could solve this using substitution by identifying that we're talking about numbers greater than 0 that are odd, and we want to choose easy to work with numbers. So maybe we could say A is equal to 3 and B is equal to 5. C is an even integer, so again we could maybe pick C to be equal to 2. You could substitute these values into these expressions and check whether the expression is indeed odd or whether it results in an even output. If it's odd, then you would count it as true. If it resulted in an even output, you would count it as false. However, we want to get past that in order to think about these conceptually and solve these in a quicker manner. So statement 1, the quantity A times B, that's the same thing as an odd times an odd. And then we're going to have quantity minus B times C. That's an odd times an even. An odd times an odd will always result in an odd output. Oops, excuse me. And an odd times an even, I'm going to put that in parentheses, an odd times an even will always result in an even output. An odd minus an even will always result in an odd. So statement 1 is going to be true. If statement 1 is true, notice that I can eliminate immediately answer selection B because it doesn't contain statement 1. Statement 2 says 2 times the quantity A times B, quantity minus 3. So don't be thrown off that they put in actual numbers here. 2 is an even number. You just relate it back to the relevant characteristics according to the context of the question. Here they're talking about even versus odd, so characterize 2 as just an even number. Times A times B, both of which are odd. So we have an odd times an odd. And then we have minus 3. 3 is an odd number, so we're just going to have quantity minus an odd. So inside the parentheses, an odd times an odd will always produce an odd. So we're going to have an even times an odd, quantity minus an odd. An even times an odd will result in an even, so we're going to end up with an even minus an odd. An even minus an odd will always result in an odd. So statement 2 is also true. So if statement 2 is true, notice we can eliminate answer selection C. So we're down to a 50-50 shot. It's either statements 1 and 2 only, or it's statements 1, 2, and 3 if, depending on whether statement 3 is true. Statement 3 says 5A times the quantity 2C plus 3B. So again, just label the numeric values according to their corresponding characteristics. So 5 is odd. So we're going to have an odd value times A, which is also an odd value. Quantity times 2 times C. 2 is an even. C is an even. Plus 3, which is an odd, times B, which is an odd. Now this one's a little bit more involved. So on the outside, at the very beginning of the parentheses, we have an odd times an odd. An odd times an odd will always result in an odd value. Inside the parentheses, we want to do multiplication first. So we have an even times an even. That will result in an even. Plus an odd times an odd. That will result in an odd. Notice that an even inside the parentheses, an even plus an odd will always result in an odd. So inside the parentheses, even plus odd will always result in an odd. And then an odd times an odd will always produce an odd product. So statement 3 is also true. So your answer here is going to be answer selection D, which is statements 1, 2, and 3. If you have any questions at all, please feel free to drop me a comment. Otherwise, let's look at 3. Question 3 says A, B, and C are positive integers. If A is less than, there should be a period there, my apologies. A, B, and C are positive integers. If A is less than C and C is less than B, then which of the following is or are negative? Statement 1 says B minus C. Statement 2 says C minus A. Statement 3 says A minus B. Answer selection A is statement 1 only. Answer selection B is statement 2 only. C is statement 3 only. And D is statements 1, 2, and 3. That should be plural. Statements 1, 2, and 3. So I'll give you 3 minutes and then I'll give you the solution. Okay, so if we look at number 3, they say that A, B, and C have to be positive, so we know that they're greater than 0, and they say that they're integers, so we know that they're whole numbers. So we're talking about 1, 2, 3, 4, so on and so forth. We also know that A is less than C, and C is less than B. And we're evaluating on the basis of positive versus negative. We're looking for which of these statements will turn negative. So I'm not interested in even versus odd anymore. Now I'm interested in negative versus positive. And namely, since all of these are positive and we have different subtraction operations, or we're taking differences here, I want to think about these conceptually as understanding that A is relatively a small number, B is the middle number, C is the middle number, and B is the large number. So I'm just going to, and I don't know exactly what all of these values are. We don't at all. They don't tell us. But we do know A is less than C and C is less than B. So A has to be the smallest and B has to be the largest. So in the statement B minus C, I can think of this as B being the large number minus C being a smaller number. Now this is all relative, of course, but relative to B, C is small if C has to be less than B. If you have a large positive number and you subtract a small positive number, your result has to be a positive. Because remember that the value will take the sign of the larger magnitude. So the large value being positive, being taken away from by the small number, is not going to affect its positivity. It's not going to draw it over 0 because the large number is farther away from 0 on a number line than the smaller number. Statement 2, C minus A. Well, C relative to A is large. So again, we have a large number, a relatively large number, minus a relatively small number, according to the context of this question. And so again, that will always have to result in a positive value. That's, of course, given the fact that these A, B, and C are positive. If A, B, and C were negative, this would be a little bit trickier. And statement, so far we know that these two are false. So we know that the answer in fact here has to be C, because it's the only one that does not include statements 1 nor statement 2. Statement 1 nor statement 2. But let's go ahead and check this anyway. So statement 3 says A minus B. Relative to A, B is large. So this is going to be the reverse of what we've been doing in statements 1 and 2. Now we're going to have a relatively small number minus a relatively large number. If you take a small number and subtract a large number, you have to get a negative result. So statement 3 is true, and your answer here is going to be C, statement 3 only. As always, if you have any questions at all, please let me know. Otherwise, let's look at number 4. Oops, sorry about that. Question number 4 says, A, B, and C are negative integers. If B is less than A is less than C, then which of the following is or are positive? Statement 1 says C times the quantity A minus B. Statement 2 says A times the quantity B minus C. Statement 3 says B times the quantity C minus A. And answer selections A, B, and C are statement 1, statement 2, and statement 3, respectively. And answer selection D is statements 1, 2, and 3. So I'll give you 3 minutes, and then I'll give you the solution. Notice here, I'll give you a little hint and preview. This might be a little bit overwhelming to solve conceptually. So this is a prime opportunity to use the substitution method because you have a lot going on and then you're adding in also that all of these values are negative. So it might be helpful to pick acceptable values for A, B, and C, substitute them into the statements 1, 2, and 3, and then evaluate. Okay, so I'll give you 3 minutes, then I'll give you the answer. Okay, so because this has a lot of it's going to involve a lot of negative values, and then on top of it we have subtraction involved. There's going to be double negatives. It might be easiest to substitute some values in here because it could be a little bit confusing otherwise. So A, B, and C are negative, and B is less than A, which is less than C. So B has to be the smallest, but remember that negative values are counterintuitive, so they're going to have the smallest value. The smallest negative value is going to have a larger magnitude than the largest negative value, right? -1 is a larger number than -100, for example. It's better to owe somebody $1 than it is to owe somebody $100. So that's where it's going to get a little bit confusing and why we might want to just pick values to test. But C is going to be the largest. So let's say that B is equal to -3. Let's say that A is equal to -2. And let's say that C is equal to -1. Therefore, B is the smallest negative value, A is the middlemost negative value, and C is the largest negative value. So substituting in, we'd have -1 times the quantity -2 minus -3. We can use leave, change here. So inside the parentheses, leave the first sign alone, change the operation, change the sign of the third value, and that becomes a little bit easier to think about. You can also do that two negatives make a positive. That also works, but sometimes the two negatives aren't next to each other, so it's a little bit harder to see. So -2 minus a -3 is the same exact thing as -2 plus a +3. and that's going to be positive 1. So we're going to end up with negative 1 times positive 1. That's going to be negative 1, which is negative, so statement 1 is false. If statement 1 is false, we can eliminate answer selections A and D. Statement 2, substituting in these values, we'd have negative 2 times the quantity negative 3 minus negative 1. Again, we're going to do leave, change, change. So leave the first sign, change the operation, change the second sign. Negative 3 minus a negative 1 is the same exact thing as negative 3 plus a positive 1, which is going to give us a negative 2. So we're going to end up with negative 2 times negative 2. That will give us a positive 4. So statement 2 is true. So given the fact that only answer selection B contains statement 2, I know that this has to be true. But I'm going to go ahead and prove that statement 3 is false just to make sure we didn't make a mistake. So substituting into statement 3, we'd have negative 3 times the quantity of negative 1 minus negative 2. Using leave, change, change, I'm going to leave this first sign alone, change the operation, change the sign of the second value. So negative 1 minus a negative 2 is the same exact thing as negative 1 plus a positive 2, which is going to turn into a positive 1. So we're going to have negative 3 times a positive 1. That is negative 3. So statement 3, in fact, is false because it's not positive. So your answer here would be answer selection B. As always, if you have any questions, please let me know. Otherwise, this will be the last problem for today. I'm going to give you 3 minutes, and then I'll give you the solution. Excuse me, question 5, and the question states, I keep on forgetting to do that, I'm so sorry. If a and b are positive integers and 6a plus b is equal to 13, then which of the following must be true? Statement 1 says a is even. Statement 2 says b is odd. Statement 3 says 2ab is odd. Answer selections A, B, and C are statements 1, 2, or 3 only, and answer selection D is statements 1, 2, and 3. So I'll give you 3 minutes and then I'll give you the solution. Okay, so question number 5. We can solve this, again, either using substitution or solving conceptually. If we solve using substitution, you might see that 6 times, first of all, they both have to be, A and B have to be positive integers, so they have to be greater than 0 and they have to be whole numbers. And 6 times A plus B is equal to 13. 13 is not a relatively large number, so notice that if we can't use negative values here, then there's only going to be a limited combinations of A and B values that are going to work, because 6 times A is going to make that 6A expression increase very rapidly, right? There's only two factors of 6, two multiples of 6 that are less than 13, 6 and 12. So there's not going to be very many values of A that we're going to be able to use in order to have enough room left over to add B and still get 13. So using substitution, we could maybe start systematically with the smallest positive integer, which would be 1. So let's say that A is equal to 1. If A is equal to 1, then we would get 6 times 1 plus B is equal to 13. So 6 plus B is equal to 13. So B would have to be equal to 13 minus 6, which is 7. So when A is equal to 1, B is equal to 7. Let's go one more and see what happens when A is equal to 2. If A is equal to 2, then we'd have 6 times 2 plus B is equal to 13. 6 times 2 is 12, so we'd have 12 plus B is equal to, 13. So B is going to be equal to 13 minus 12, so B is equal to 1. So when A is equal to 2, B has to be equal to 1. Notice that we cannot use 3 for A, because 6 times 3, there's no way to have 6 times 3, which is 18, plus another positive number, because B has to be a positive integer, they say. We can't add a positive integer to 18 and get 13. You would need a negative integer to do that. So notice that is the restriction on our domain here. We can't use any other value greater than 2 for A. So we have these combinations here, and we could solve using this alone. I do want to point out, sometimes they throw some statements at you that are blatantly false. If you investigate statement 3, notice it says 2 times A times B is odd. If 2 is multiplied by anything, 2 is the only even prime number. So if you multiply some values by 2, that result will be divisible by 2. Any number divisible by 2 is necessarily a multiple of 2 and is therefore necessarily an even number. So there's no way, it's a mathematical impossibility for 2 times A times B to be odd if A and B are positive integers. So this statement 3 could never be true, so we know immediately that this is really a 50-50 shot between statement 1 or statement 2. And from the systematic listing out of A values, notice that A was equal to 1 or could be equal to 1, and A could be equal to 2. So A could be positive or negative. So statement 1 is false. Statement A does not have to be even. A could be odd, as we saw in the first example where A is equal to 1 and B therefore is equal to 7. So by process of elimination, the answer here is B, statement 2 only. B is always odd, and you can see that here, when A is equal to 1, B was equal to 7. When A is equal to 2, B was equal to 1. 7 and 1 are both odd values. So B has to be odd. You could have also solved this conceptually, which I want to go through. So we have 6 times A plus B is equal to 13. So turn these into the relative, or I should say evaluate these expressions, these monomials, each part of the equation. Evaluate each part of the equation based on the relevant characteristic that the question is testing. So here we're talking about even versus odd. 6 is an even number. So we're going to have an even number times A plus B is equal to an odd number. 13 is odd. Well, what do you know about an even times any number? An even times an even will result in an even product. An even times an odd will also result in an even product. So this has to be an even value. So this would turn into an even plus B is equal to an odd. If we subtract away an even on both sides, notice that B has to be equal to an odd minus an even. An odd minus an even is always odd. So you could solve this conceptually as well and see that answer selection B, or in other words, statement 2 only, is the only true mathematical statement listed here. If you have any questions, then please let me know, either in the live chat function or in the comment section below. But otherwise, I really appreciate you watching my stream. Thank you very much. There'll be more videos to come, and if you found this to be helpful, please like, favorite, and subscribe to my channel. Otherwise, Dr. Tot, do you want a cookie? Well, let's see if Dr. Tot will say goodbye to everybody. Oops, I dropped his cookie. Come on, Dr. Tot, you got to say goodbye to everybody. Come on, I know you've been sleeping. Come on, you want a cookie? You gotta say goodbye to everybody. Come on. Come on. You gotta say goodbye. Dr. Todd is very tired today. Can you say bye? Can you say bye to everybody? Well, you guys do good. Okay, we're halfway there. Well, thank you very much, everybody, for signing in, and I'll talk to you all soon.